India is the fourth largest automobile market in the world and is projected to become the third largest in the year 2021. This increased mobility has a downside. More vehicles on the road means greater emissions, more pollution. India also imports 83% of the oil it consumes, making it one of the biggest importers of oil in the world. Which is why there is an ambitious target pushing for 30% of our vehicles to be electric by 2030. How will we achieve this? What is our manufacturing capacity to make these vehicles? How will we set up the charging infrastructure to support the use of these vehicles? How will India manage to be fully self-reliant as far as electric mobility is concerned? One of the highest sources of pollution in India is from vehicles. Emissions from fossil fuel-powered vehicles contribute 60% of particulate matter in atmospheric pollution and over 20% of CO2. Nearly two-thirds of deaths from air pollution can be attributed to diesel vehicle exhaust emissions in India. Electric vehicles, EVs, are a positive and sustainable way forward. They run completely on electricity and do not emit deadly hydrocarbons. The EV manufacturing ecosystem in India is still in its nascent stage. To propel this, the government has been putting many robust policies in place that can help this sector. In our journey to self-sufficiency, there is the hope that India will become a global hub in this area. Companies like Hero Electric Vehicles Private Limited can play a big role in this journey. They are pioneers in the Indian electric two-wheeler industry. 10 years back, this company started moving into the manufacture of electric two-wheelers.
When we launched effectively in 2007, we created a separate company, launched a completely separate, got in a separate team. I was very clear at that point that this team has to be completely 100% focused on this sector. It cannot be that we are a subsector or a sub-company of one of our larger companies. Simply because this requires even more attention to detail than what the conventional businesses were at that point. But very clearly, the writing on the wall for the past number of years has been that we have to move towards cleaner vehicles. We have to move away from polluting vehicles.
So, how does an EV work? All electric vehicles, EVs, have an electric motor instead of an internal combustion engine. The electricity saved in the battery powers the motor. This is the biggest difference to internal combustion vehicles, in which the engine exhausts fossil fuel to generate that power. As such, EVs have no need for the engine and transmission, the two of the most crucial components for internal combustion vehicles. Since there is no burning that happens, there are no emissions as we find in conventional two-wheelers. Electric vehicles have no clutch or gears, so there is no friction that happens in the engine itself, since there are less moving parts. The electric motor converts the electrical energy to mechanical energy, which is what moves the vehicles forward.
It's basically a battery which is rechargeable. And it depends on what technology you're using, so that battery could be recharged a few hundred times to a few thousand times. It will last you a few years to many, many years depending on how you're using it. So it's a very clean vehicle. There is absolutely no emissions. There is, for a driving experience, it is a great experience because the torque is very good. There's no vibration, there's no sound. That's a very important factor. No polluting vehicle at all. Convenience, ease of use, and it gives you clean mobility.
The best part of the electric vehicle is that there is a huge drop in the amount of emissions. This leads to cleaner air in our cities and better health for citizens. In comparison to the conventional motorbikes which run on petrol, electric two-wheelers are both cheaper to purchase and maintain. How is the electric vehicle assembled? The first station has a frame, which is also called a chassis. The chassis gets loaded and then a converter and controller are added. The controller is the brain of the e-bike. All electrical signals from the horn, buzzer, headlight and indicators go from the controller through the converter. The converter converts higher voltage into low voltage 12V and supplies it to the vehicle's various electronic systems. Then the second station is the motor. The motor runs the vehicle. It gets placed in rear wheel in the hub. The third station is where the front wheel with tires are put together. The handle is added in here. Then the main harness is fitted. This runs through the whole vehicle, transmitting information and connecting a variety of components. Then, various plastic parts like the headlight and side panel are placed. After this, assembling is done. The seat is added, and then lithium-ion batteries are added. This is the final stage of the assembly. These lithium-ion batteries are portable. After the assembly is completed, the vehicles go through various quality checkpoints where every parameter of the vehicle is checked. Apart from manual checking, every parameter is further checked in electrical dynamo machine. And then, the vehicle finally rolls out from the factory. Sushant Singh is an executive working in a multinational company in New Delhi. He has recently switched his mode of commuting to office to the electric scooter.
I personally feel it is quite economical in comparison to other petrol vehicles. It is fuel efficient and it is eco-friendly to nature and it has no adverse effect on environment. It easily runs around 50 kilometers on single charge. I never had any issue regarding its range.
India has an enormous two-wheeler market. With the government pushing e-mobility and offering subsidies, this sector is expected to grow over 44% during the period 2019 to 2025. This sector is likely to spearhead the e-revolution in India. Clean mobility is clearly the way forward. To push this journey, there has been an impetus to better the quality of e-vehicles. For example, now these two-wheelers use portable batteries, which is convenient. Pushing indigenous manufacture like this helps our economy grow, makes our air cleaner, reduces our dependence on imported fossil fuels and pushes our vision of an Atmanirbhar Bharat.
We were already working on localization, but now what's happened, it's pushed the whole industry. So it's creating this job creation which is happening. Industries which didn't exist earlier, supply chains, are now falling in place. Batteries I was already talking to you about. Like this, there are many other technologies, there are many other technical products which now would be manufactured in India because of this. So it's a very good move in that direction. So there are numerous opportunities for us going down the value chain as far as we can go, whether it's even down to the raw materials, where we could have them either coming from India or being mined or owned by Indian companies.
More electric vehicles on the road is just one step of the process. What happens to the subcomponents like the battery that constitute upwards of 50% cost of an electric vehicle? As the nation progresses towards clean mobility, if there is not an adequate supply of domestic cells and batteries, India will simply go from being an oil-dependent country to a cell-dependent one. Keep watching as we explore India's battery manufacturing capacity. Right after this break.
India Science Channel was launched in the year 2019 by the Department of Science and Technology, Government of India. The internet-based dedicated science web channel is being implemented and managed by Vigyan Prasar, committed towards science communication. The channel features science documentaries, discussions on current topics, interviews, and different programs covering the entire landscape of science and technology to make science popular among the masses.
India Science is a flagship project of Vigyan Prasar, and over a year and a half we have produced more than 1,200 videos of different sizes, lengths, and are from different genre and for different domains for the people of the country. We've taken, we have spoken, we've gotten, we've dived deep into the realms of different domains of science and technology. And we have gotten news, stories, films, videos in almost every format that you can think of. OTT, for that matter, is a great platform that helps anybody to look for any news, any item, any video, any documentary at any point in time. All you need to do is to subscribe a channel for it.
One can also download India Science mobile app from Google Play Store or Apple Store to view this channel.
The Indian government has been working on pushing e-mobility. Some plans even envision 100% conversion to electric by 2030. But to achieve this, we need to push the growth and manufacture of the lithium-ion battery indigenously. Currently, India is dependent on other countries for sourcing EV batteries, which has resulted in the high price of these vehicles. The best way to alter this is to be able to manufacture the batteries indigenously. Let's look at the lithium-ion battery in a bit more detail. It's composed of mainly 4 components: the cathode, the anode, a chemical called an electrolyte between them, and a separator. The anode and the cathode store the lithium. The electrolyte carries positively charged lithium ions from the anode to the cathode and vice versa through the separator. The movement of the lithium ions creates free electrons in the anode, which creates a charge at the positive current collector. The electrical current then flows from the current collector through a device being powered to the negative current collector. The separator blocks the flow of electrons inside the battery. While the battery is discharging and providing an electric current, the anode releases lithium ions to the cathode, generating a flow of electrons from one side to the other. When plugging in the device, the opposite happens. Lithium ions are released by the cathode and received by the anode. A lot of energy can be stored in lithium's atomic bonds. This translates into a very high energy density for lithium-ion batteries. A typical lithium-ion battery can store 150 watt-hours of electricity in 1 kilogram of battery. These batteries are generally much lighter than other types of rechargeable batteries. They find use in portable electronics, electric vehicles, and even at power stations to provide uninterrupted power supply. The lithium-ion battery manufacturing industry in India is at a nascent stage at present. However, the country holds the potential to emerge as the key manufacturer of these batteries over the next few years. Companies like Okaya Power Private Limited could be key players in this growth story. They have been making batteries of various kinds in India for almost 30 years, including inverter batteries, solar batteries, and e-rickshaw batteries. Now they have also started manufacturing lithium-ion batteries and EV charging solutions in order to play a role in pushing the national e-mobility mission.
Our vision in Okaya Power Group has been very clear. We are into the residential as well as commercial industrial storage and mobility application into electric vehicle batteries, storage batteries and electric vehicle charging station. Our goal is to provide the products which can actually help and create a sustainable future for our today's generation and the generation that is yet to come.
With the realization through COVID pandemic that India needs to be less dependent on foreign supply chains, the government pushed the idea of an Atmanirbhar Bharat. A step in this direction was incentivizing companies to manufacture in India. The Indian government raised tariffs on lithium-ion batteries. This tariff hike made the cost of importing these batteries from countries like China costlier. They have also brought down import costs of certain components to push indigenization. This has led to a host of Indian companies who are pushing their manufacturing and skill capacities to work on developing these batteries. With their enormous experience in battery making, Okaya had the required expertise and resources to manufacture lithium-ion batteries for EVs. The overall process of lithium-ion battery manufacturing includes the production of cell components, electrode, electrolytes and separators, cell and module production, battery pack assembly and integration of components. The assembly and manufacturing of EV lithium-ion batteries takes place in their factory in Baddi, Himachal Pradesh. The process starts with the testing of individual cells in a cell capacity machine. Tested cells are then taken to the assembly table. Here, the cells are placed in sequence of negative in one line and positive in the other. The cells are then put into an automatic spot welding machine which connects the cell together with nickel strips. Then, the BMS or battery management system is assembled. Okaya manufactures their own BMS. Then wires are connected to the BMS. This is called wire harnessing. After that, the BMS gets connected to the cells. Then the whole battery is tested in a battery pack testing machine. After it passes the test, the battery is sent for packaging.
We have our electronics BMSs in place which help to monitor, control the individual cell performances, and they control the output to the motor, that is taking in the current in order to drive the vehicle forward. On top of that, there are a lot of safety and security mechanisms which are in place, whether it's the thermal conductivity, it's the thermal runaway prevention, or it's the electronic protections that are going into place in order to make it a safe battery.
This kind of technology and innovation, along with the backing of government schemes, could truly accelerate our manufacture of electric batteries, a big part of our movement to e-mobility in India.
We are 100% confident that India as an economy, not just our company, but there are many other companies, we are all working together to indigenize as much as possible. And I really feel this is going to help us make the consumer come faster towards the product because of the cost implications that are first hand there. Awareness is there, availability is now there, but now it's just the element of cost which we have been able to fight. But again, to get the penetration down to tier 2 and tier 3 cities, it further needs to be bridged. And Atmanirbhar Abhiyan is going to be one of the most critical projects which the government has laid out.
Manufacture of e-vehicles, the pushing of our e-battery economy are both critical steps. After this break, we explore ways in which India has helped reinforce the infrastructure to push more people to switch to electric vehicles.
India Science Channel was launched in the year 2019 by the Department of Science and Technology, Government of India. The internet-based dedicated science web channel is being implemented and managed by Vigyan Prasar, committed towards science communication. The channel features science documentaries, discussions on current topics, interviews and different programs covering the entire landscape of science and technology to make science popular among the masses.
India Science is a flagship project of Vigyan Prasar. And over a year and a half, we have produced more than 1,200 videos of different sizes, lengths, and from different genre and for different domains for the people of the country. we've spoken, we've dived deep into the realms of different domains of science and technology, and we have gotten news, stories, films, videos in almost every format that you can think of. OTT, for that matter, is a great platform that helps anybody to look for any news, any item, any video, any documentary at any point in time. All you need to do is to subscribe a channel for it.
One can also download India Science mobile app from Google Play Store or Apple Store to view this channel.
India has upped the manufacturing of electric vehicles and pushed the technology to manufacture batteries indigenously, both critical steps. But electric vehicles are not going to become a feasible option on the ground unless we have the infrastructure in place to support the shift to electric. There need to be appropriate policies and regulations on the ground to make charging infrastructure available in both public and private spaces. Assuming the infrastructure is in place, 90% car owners in India are willing to switch to EVs, according to a survey by the Economic Times in May 2019. At present, however, EV market penetration is only 1% of total vehicle sales in India. This is where companies like Energy Efficiency Services Limited (EESL) will play a critical role. The mandate of EESL is to facilitate energy-efficient projects to enable consumers, industries and governments to manage their energy needs through energy-efficient technologies. To do this, EESL is working on creating an environment to push e-mobility and provide the necessary EV charging infrastructure in the country. For example, in an attempt to push Indian e-vehicle use, they have procured and deployed over 1,500 e-cars in government organizations. These e-cars are being given on lease basis to replace the existing petrol and diesel vehicles used by government organizations.
Our aim when we started off the EV program is to create a market, make sure that EVs function the way they do. All its benefits are known to people, and that's how we got in first electrifying the government fleet. Now we are also providing these vehicles to e-taxi operators and also laying out charging infrastructure, which is necessary for a full-blown EV revolution in the country.
To push other consumers to access the benefits of an EV, EESL has worked on a rapid scale-up of charging infrastructure in the country. One of the main capital requirements to set up charging infrastructure is the availability of land, which as of now is provided free of cost by most municipal bodies or firms for public chargers to EESL. Till now, EESL has installed 350 EV charging stations with plans to increase this. EESL is partnering with local bodies, institutions and state governments to establish public charging stations. A key challenge while creating these charging stations is the development of equipment that can support faster charging. There are also a variety of connector options for different cars.
And the various type of chargers which are there are for the lower range cars like Tata Mahindra and e-Verito, which travel around 120 to 140 kilometers. Those chargers are DC 001 15 kilowatt. Then we have high range cars like Tata Nexon and Hyundai Kona, which have range in 250 kilometers plus. For that we have higher 142 kilowatt chargers of CCS CHAdeMO types.
The charging stations installed by EESL are customer friendly and can be used with the help of a mobile application called Electrify. By simply logging in with a user ID and password, a user can locate the nearest charging station compatible with their vehicle. Then, by quick scanning the QR code on charger, the user can select how he wants to charge the car, by battery capacity, by time, by units or by money. After that, the charger is plugged into the slot on the vehicle and it can be charged.
If you are running a diesel or a petrol car in Delhi, the cost per kilometer is about 6.5 rupees. If you are charging your electric vehicle at 10 rupees per unit, your cost is only about 1 rupee 10 paisa. Now imagine if you can charge it at 3 rupees per unit using renewable energy. This is something which is a revolution waiting to happen, and it is completely Atmanirbhar because you are not dependent on fossil fuels.
EESL intends to set up carbon-neutral charging stations by bundling solar rooftop, battery-based charging stations and battery swapping stations. Eventually, the company plans to set up 10,000 charging stations over the next 2 to 3 years across the country.
The government has also allocated 1,000 crores as subsidy for these stations to come up. There is a process that the Department of Heavy Industry is following, and they have already allocated about 2,600 odd charging stations. And they have just come out with a bid for about 14 expressways and highways. So initially the idea is to first populate the 1 million plus cities, state capitals, so that we have enough charging stations and enough enthusiasm and interest of OEMs to bring in new models of EVs.
To further push electric mobility, the Government of India has incentivized the usage of electric vehicles by cutting down the GST, reducing road tax and registration fees.
So if you push people towards electric mobility, charge them using renewables, you achieve 2-3 things. Number one, you are self-reliant, Atmanirbhar in energy. B, it is a green energy which is powering your transport.
More electric vehicles on the road will be a game changer in India in terms of our dependence on exported fossil fuels. It will also support environmental sustainability and lower carbon emissions on a national scale. The coming together of public and private institutions to push our electric vehicle agenda is truly an example of how India can move to be self-sufficient.